Thanks, Martin. So in this talk, I'll be describing the various resources being developed by NOIRLab and Gemini in particular to enable time domain astronomy, which is being shaped by a surge in data rates and data volumes from modern surveys. An important source of the data surge in the immediate future is going to be Rubin Observatory's Legacy Survey of Space and Time, or LSST. And there you can see the expected numbers for its data. So we'll be seeing several hundred petabytes of imaging data over its 10 years of operation. We're expecting up to 10 million alerts every single night. And of these, just a handful of sources can be followed up on any given night. So to do time-critical science with this barrage of data, specialized software infrastructure along with efficient data mining algorithms are a necessity. So for present and upcoming large-scale surveys, this ecosystem will be the paradigm for doing real-time science. So apart from the Rubin facility, the encircled components that you see there are resources from NOIRLab, thus highlighting its capabilities to provide end-to-end support for time domain astronomy. So we'll have millions of alerts generated by these surveys, which will then be distributed near real time to what we call as event brokers. Antares is one such broker developed by the CSDC program of NOIRLab. These events or alerts will be processed by various science filters running on Antares to find the most interesting transient events. The science filters, in turn, can be readily developed on the NOIRLab Astrodata Lab science platform. Then there's few tens of the most exciting events flagged by Antares will be followed up using a rapid response coordinated network of facilities, that is AON. And within the AON network, Gemini will provide the largest class. We'll hear more about AON from Brian Miller in the next session. Then once the data are gathered, they will be automatically reduced by modern data reduction tools, notably Gemini's Dragon software that we heard about from Kathleen this Tuesday. Dragons will generate rapid turnaround, quick look data in order to help the user assess requirements for further time critical follow-up observations. Finally, using the data reduction package, the user can also generate science-ready data products to make discoveries, perform characterization, and use the results to feed back to the brokers to improve the filter, or they may decide to trigger further follow-up observations to trace the late-time evolution of the transient. In the next few slides, I'll focus on the Antares alert broker. So Antares has been processing the alert data from the Zwicky ongoing Zwicky transient facility. The ZTF alerts are generated at IPAC and are distributed via a server hosted at the University of Washington. These ZTF alerts are then processed by Antares using multi-level filters. And in the processing, the broker Antares adds values to the raw data of the alert. An example being, cross-matching the alerts with various legacy catalogs in different wavelengths. This will help to identify the high priority events. The filtered events are then delivered to the community via multiple services. So we've got Slack, then there is a Python client library, then we've got a toolkit for exploring the value-added Antares database. This toolkit can also be used to develop filters on the Astrodata Lab platform. And finally, there's a web portal that you can access at www.antares.noirlab.edu. Okay, I'm going to skip this slide to save some time. Next, I'll highlight Gemini-specific resources, which will cement its leadership for time domain follow-up in the Rubin era. So the plot on the left-hand side is the distribution of the optical peak magnitudes of extragalactic alerts from ZTF. So these alerts comprise various types of supernovae. And as you can see from the plot, more than half of the sources, they have their peaks fainter than around 18 Mach. So for one-time follow-up, the arrows indicate rough aperture requirement. But the problem is this is just the peak of the transient. And what we want to do is to trace the evolution of the event in different wavelengths for us to investigate the underlying physics. So to monitor rare and exciting events like fast blue optical transients or F-boats that we'll hear more about in the next session, facilities capable of rapid response are a necessity. So there you can see two example light curves of F-boats to highlight the rapid decay. So they decline by like 1 magnitude in a single day. So to capture these events, rapid response facilities, they are a requirement. Now, to specifically focus on Gemini for time domain alerts, it's not just the aperture size it offers, but a whole suite of instruments ranging from the optical to the near IR that we heard about in this meeting. Then, of course, there is Scorpio under development, which will simultaneously cover both visible and near IR, and it will be used for dedicated LSST follow-up. So Scorpio, combined with Gemini's capability for queue scheduling, will make this facility unmatched and a game changer for in the follow-up ecosystem. Now, for real-time applications, the turnaround time from observations to reduce data is also important. And on that front, of course, we have Dragon's program in place. And Dragons will play a critical role in closing the time domain follow-up loop. Okay, so in the remaining time, I will demo how the various Gemini and NOIRLab state-of-the-art services are enabling end-to-end automation of the time domain astronomy process. So I'm gonna change my screen to a notebook, and I'll be executing this in this demo. I'll run this block by block so people can follow. So here it goes. The purpose of this notebook is to demonstrate the integration of these three key services for time domain observations. So we'll have Antares for the target selection. Then we'll trigger follow-up observation on Gemini using the Target and Observation Manager or TOM toolkit. So this is a web application framework developed by the Las Cumbres Observatory to enable triggering observations on facilities within the AON network programmatically. Then we'll retrieve and reduce the observed data using Dragons. Okay, so let's start with Antares for the target selection. So here I'm importing the client library of Antares. And this is the target I have selected for this demo. This is flagged by a filter I wrote called Novatest. This finds explosive transients. It's a pretty stable filter, but I didn't get a chance to rename it. Okay, so this event occurred in this blue spiral galaxy, largely likely a star-forming galaxy. Fortunately, the galaxy was observed by SDSS, so we have spectroscopic redshift for it. And here's the ZTO flight curve of this event, retrieved using the Antares client. So as you can see, there are two outbursts separated by almost a year. And if I apply the redshift of the apparent host, then these peaks are brighter than an absolute magnitude of -19, which makes it pretty interesting. We discovered this event around the second burst, and we were scrambling to get a spectrum for it. Fortunately, around this epoch, we got GMOS spectroscopy time with Gemini. So in this demo, I'm going to replicate the Gemini observation, but now using the TOM toolkit for triggering the follow-up. So Gemini is now TOM enabled thanks to a software plugin written by our own Brian Miller. And to use the API, I need to import these libraries. Then I create this target object, which will be loaded with the properties of the transient selected from Antares. And then triggering a Gemini is relatively straightforward. So we submit, we create this form where we specify the constraints for the observing parameters. And then in this single line of code, we submit this form. So basically we trigger the observation. One can also use a locally deployed web application to manage these observations. And here is the user interface that is running locally the background for me, built using the Tom Toolkit library. And for the purpose of this demo, I just wanted to highlight how the record of this trigger looks like within that interface. So I made a test trigger December last year. And oops. Okay, let's hope it works. This is a live demo, so things like that happens. All right. Okay. Anyways, you can I can show this offline, but it does work, and you would see a record of this event. Okay, let's proceed. This is anyway. So the trigger is done. The data is gathered. It will be ingested in the Gemini Observatory archive within minutes, and so we can now proceed with the reduction. The first step here is to locate the data in the archive, and we'll do this programmatically using the archive API. But first, I'm going to use the thank you, the Gemini Astro Query module to gather information about this target. So, for example, the observation ID. This is integral to download the data with the API, and then I make this I do the download in this 4 blocks of code. So data is now in my local file system, and I can proceed with the Dragon's reduction. I'm going to use the API for this process. It's now importing the Dragon's libraries. And if you attended the workshop, Dragon's workshop on Monday by Kathleen, how the reduction proceeds is we first systematically create file lists, and then we process the calibration frames and finally reduce the science data. So let's go ahead and make the file list. So here's the bias file list, the science target file list for the flats, the arcs, and the standard star. And now we can proceed with processing the calibration frames. So in this block of code, the master bias is generated. And then here we process the flat frames. And one thing I want to highlight here is for this demo, I'm using the 3.1 version of Dragons, which we expect to release early next year. And that version will come with enhanced capabilities, one of which are these powerful interactive tools that the user can, that will help the user to optimize the data reduction process. So as an example, for the flat processing step, one will be able to interactively fit the wetland structure of the flat fill using this tool. And then I'm determining the wetland solution here. And for this step as well, one will be able to interactively find the arc lines, interactively perform the fit. And now reducing the standard star, which will be used for the flux calibration. And for this step as well, we should be able to fit the sensitivity curve there. And finally, going to the science target. Fortunately, we have a clear trace in 3 exposures for this transient. And using those process calibration frames, I'm reducing the science exposures in this block of code. And for this step as well, one will be able to use this tool to interactively find the aperture. Okay. As well as interactively trace the aperture. And finally, this is the Dragons generated wetland and flux calibrated spectrum of this transient. So this Gemini observation, it helped us to classify that the target as a type 1A supernova. And the story is those 2 outbursts were actually 1A siblings that occurred in the same galaxy. So they were pretty close by, separated about 1 kiloparsec or so. But anyways, as I showed in this demo, we can perform this whole process of time-domain astronomy, target selection, triggering observation, data reduction, all within this single notebook And that is thanks to the services developed by Gemini and other programs of NOIRLab. And I'll end my talk with this slide as a short promo. It is contingent upon funding from the NSF, but if we do get it, then we plan to develop this interface called GOATS, which stands for Gemini Observation and Analysis of Target System. And GOATS will provide a seamless integration between these various services so that you don't need to learn 3 or 4 different APIs to interact with the different services individually. I'll be happy to take questions. Thank you.
Thank you, Monica. That's an excellent summary. So now we can take some questions from the room and from online. Clara is managing the online contributions. Nothing so far, but we'll give them some time to type. Are there any questions in the room anybody would? I encourage everybody to stand up, and there's no such thing as a stupid question, as you'll find out if you force me to ask them. So don't do that, and come forward yourself and do the same. So while you're thinking, Monica, so this afternoon session after the time domain session is all about adaptive optics. And I noticed in your list of facility capabilities, in the south, you have GEMS in your list, and in the north, Gemini is working on GNAO, which will be replacing the Altair system. Is there anything that you can talk to which will describe the unique contributions that users will have using these 2 Gemini systems that will help us in time domain astronomy?
Oh, with adaptive optics, oh my gosh, yeah, you can do lots of things. I can talk about my own personal program. I'm pretty interested in variables in clusters, stellar clusters. So for example, Andromeda, clusters in Andromeda. And of course, like, you know, we do not, the only facility that's capable of resolving these clusters is HST. And if, you know, with all these AO facilities coming live for Gemini, there is like enormous scope to study these sources in crowded fields. So much to be learned from these variables from clusters. You can leverage properties of the clusters in order to, you know, like study the driving mechanism of these variables. Then of course, I think it's not my field of expertise, but for the supermassive black hole binaries, adaptive optics a big deal. Like I know that there are groups who are vying for AO time to actually, you know, resolve the binaries if possible. I think Shin Li's group from University of Illinois, that's one group. They have a program using Gaia data where they use the astrometric, I think it's called barometry, or I'm blanking out on that, but they use changes in the centroid of the Gaia observation in order to find possible targets, and then the selected targets will followed up with AO system. So there are lots of things to be done. So.
Yes, very exciting. Can't wait for this to happen in the north, especially. Yes.
Teresa question on Slack.
Great. Let's do Zach first, and then go on to online.
Hey, Monica, great talk. So, I mean, this demo was really nice in the sense that you showed off, okay, already we can get Gemini data and have it reduced already with the alert system. How is GOATS going to dramatically improve that?
Right. What I can tell you is with the entry barrier is pretty high, because you realize that I actually have 3 software installations to kind of like interface these services. Like Antares, there's a different interface, API that I have to install. There's the archive, Gemini Observatory archive. It's fabulous, but you know, these services, they aren't really talking to each other. It requires the user to make the connection. Now, in order to reduce that entry barrier, imagine this interface where all of these things are abstracted, right? Like as a user, I don't want to spend time, you know, trying to figure out how to do the installation and then learning how to use the API. What I want to do is to focus, you know, on interpreting my science results. So that's basically what GOATS will achieve. And of course, it will have like added functionalities on Dragons that will add the analysis part to it, where, you know, you can do things like splot, the RF standard splot, where you can find line profiles, properties, equivalent widths, do redshift scaling, and all these things. That, you know, me as a time domain astronomer, I'd have to go to a transient name server. This is another service, and upload my spectrum, try to do the line list analysis, or do it on a notebook separately. So I want to do away with that and have it everything on one platform. So that's basically the plan.
Thank you.
Okay, let's go over to Clara online.
Okay, Joel Rodriguez is asking, once the observation form is submitted by a user, does Gemini receive a treat the request like a RTO trigger?
I totally believe so, because so that was the test trigger, and Brian is the guy here who made that possible. So I am so Brian, myself, and I guess there is a test mailing list that when I make the trigger, Brian receives the email as an RTO, a test RTO, as well as myself. So I know that has happened.
Sorry, the specific answer to that question is it depends. It can be either rapid or standard depending on what template you've used for the trigger.
Thank you.
Okay, thank you, everybody. Thank you, Monica. Let's thank Monica one more time.